This recording is over. The properties of a triangle, finding the missing interior measure of a triangle when given the two other interior angles. So let's look at our number routine. Negative 4b is less than or equal to 20. So this is the graph. Let's see if this graph, let's take a test. 0. Is 0 greater than negative 5? It is. So if I multiply negative 4 times 0, 0 is less than or equal to 20. So I know that this graph is correct. But let's see why. Remember, when solving an inequality, it's like solving an equation. You need to isolate this variable b. In order to isolate the variable b, you need to do the inverse operation of multiply negative 4. So the inverse of it is divide by negative 4. Divide by negative 4. This cancel. 20 divided by negative 4 is negative 5. Now, is b going to be less than or equal to negative 5? Let's see if this works. Name a number less than negative 5, like negative 10. Negative 4 times negative 10 is 40. That's not less than 20. You have to flip the sign around. You may say, but why? Remember, this means negative is you're doing the opposite of. What's the opposite of less than or equal to? It is greater than and equal to. So b has to be greater than negative. Remember, number least to greatest. B is greater than negative 5 or equal to negative 5. And we tested out negative 4 times 0 is 0 less than 20. So it check mark. Check mark. All right, so you will be opening up your textbook to page 686, and you'll notice that there are three types of triangle. There are acute triangles, right up triangle, and obtuse triangle. So as you can tell, in case it's been a while since you learned this in elementary school, there are three types of angle. There is a, well, cannot even see it. There is a right angle, which is equal to 90 degrees. If you have an angle that is less than 90 degrees, so it's less than 90 degrees, it is called an acute angle. And if you have an angle that is more than 90 degrees, then it would be called an obtuse angle. So if you look at this, all the angles are acute angles. If you look at this, you see a right angle, so it's a right triangle. And here you see an obtuse angle, hence it is an obtuse triangle. So we know this is exactly 90 degrees. We know that this number has to be less than 90, and we know this number has to be more than 90. So I would like you to classify these. All right, oops. Let's start with the right angle. I always like starting with the right. I see a right angle right here, so I'm going to leave that there. Are there any more right angles here? Let's turn this. Oh, that's a right angle, so that stays there. Now let's do obtuse angle. Anything that's wider. Oh, this is a very, right here, if you don't see it, this is a very wide angle, obtuse, and this is an obtuse. And as I look here, I see acute angles, turn it, acute, 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 acute. So I've done a pretty good job so far. So here is a video. I know you don't hear the sound, but just look at the images. So they're supersizing triangles. Let's do his homework. He's asking what kind of triangle is this? MJ's Michael Jordan. So that was an isosceles triangle. All equal size, so he's said is an equilateral triangle. they notice that all the sides are different, so that would be called scaling. So what makes the third triangle different from the first two triangles? So in the first triangle, this was 8 centimeters, or I think it was 8 feet, I apologize. So he's doing a basketball reference, so it's 8 feet, 8 feet. And this was like 5 feet away. So you had 3 basketball players. Then you had another triangle where this was 8 feet, 8 feet, 8 feet. So he said that this was an isosceles triangle. He said that since everybody has an equal distance from everybody, this is called an equilateral triangle. But the last triangle was quite different. This was like 10 feet, 6 feet. Now let's make this, I'm sorry, let me this is like 8 feet, and this will be 10 feet. So this triangle is different from the other 3 because all the distance are different. So all the players are at different distance from each other. So that would be called a scalene. So if 2 of the distances are the same, it is called isosceles. The way I memorize it is eyes. How many eyes do you have? 2 of them. These are all equal distance from each other, so it's called equilateral. And this one, everybody is different, so it's called scale. Let me spell it better. Scalene. So we start with an isosceles. 2 of the sides are the same. We start with an equilateral. All 3 are congruent of equal distance. And then scaling, none of them are congruent. The way I memorize it again, equilateral, equal distance, equal. Eyes, how many eyes do I have? 2 of them will be the same. And scaling, when you get on the scale on 3 different days, will you be of the same weight, like to the tenths or hundredths at those 3 days? No, you'll be different weight. So that's how I'm scaling, always getting on a scale, always weighed differently. So let's classify here. I'm gonna start with equilateral. Equal distance, equal. This is an equilateral. I don't think there's any more. Eyes, how many eyes? How many eyes do I have? 2 of them. So these 2 numbers, 7 and 7. Oh, if I turn this, I see 7, 7, 9. Anything else? Oh, I see a 4, 4, 6 equal. And scaling, all of them are different distance. So what you're going to be doing is you have a problem here. Classify each triangle by its angle. Start with angle. What kind of angle is 150 degrees? Obtuse. What kind of angles do you see for B? 72, 67, 41. They are less than 90, so it must be acute. And now by its side. So in this one, these 2 look the same size. This one looks longer. 2 of them. I have 2 eyes. Oh, isosceles. And the last one, 7 feet, 12 feet, 13 feet. All of different distance. Scaling. All right, so in another activity, you'll be given all these triangles and you will sort them yourself. So the last thing we're going to be doing is a triangle. You're going to be going to this website. And on this website, you're going to be telling me what do you notice from this one. You will notice that no matter what, if you add the 3 interior angles of a triangle, it will always add up to 180. Woo! Like for example, if you have a 90 degrees or right triangle, it still adds up to 180 degrees. If you have 3 acute angles, it will still add up to 180 degrees. If you have an obtuse triangle, oh, I can move that here too. Ooh, nice. Then it will also still add up to 180 degrees. No matter what, the interior angles always add up to 180 degrees. If you would like the proof on that, Here is a triangle, 1, 2, and 3. If you tear off the vertex for each triangle and glue them together, it makes a straight line, which is 180 degrees. If you tear out the vertex of this obtuse triangle, each vertex, it still makes 180 degrees. So what you're going to be doing is you're going to go through this activity and you're going to figure out what class of, you're going to tick the boxes that apply to each triangle. Then you're going to find the missing measure of each triangle below, put the angle measure in the triangle. So let's look. All these angles look like acute angle. Check mark. And all the sides are equal distance, equilateral. Now find the measure of angle A. Well, I know it adds up to, so we don't know what A is. So A plus 60 plus 60, and a triangle has to add up to 180 degrees. So if you add up 60 plus 60 is 120 equal 180. Again, oh, this was like a one-step equation. What is the I want to isolate A. What's the inverse operation of plus 120 minus 120 minus 120? So A equals 60 degrees. So this would be 60 degrees. Now, next one. Oh, 96 degrees. That's an obtuse angle. All the two of the sides are the same. Two of them. I have two eyes. Oh, isosceles. Find the measure of angle A. So A plus 42 plus 96 equal 180 degrees. A plus, let's see, 8. 138 equal 180. Again, I do the inverse operation, minus 138, minus 138, cancel, regroup. So I got 42 degrees. Please note that when you have an isosceles triangle, you know, two of them are the same, two of the angles have to be the same. Hint, hint. Just like when you have an equilateral triangle, all the angles have to be equal to each other, just like the distance. Next one, this is a obtuse angle. All the numbers are different, so scaling. Let's find the measure of A. So we have 23. A plus 23 plus 128 equal 180. If you add 23 to 128, 11, carry the 1, 151 degrees. I do the inverse operation. So 7 minus 5 is 2, 10 minus 1 is 9. A equal 29 degrees. And just like a scalene, if all the sides are different, all the interior angles have to be different. Next one. You know, I'm not sure what kind of angle. It looks like a right angle to me, but we'll do the mathematics and confirm. And 3, 3, 4, two of them are like my eyes. Oops, isosceles. So if I add A plus 45, oh goodness, plus 45 equal 180, A plus 90 equal 180. I do the inverse operation. So A equals 90. And I was correct. 90 degrees here, 29 degrees here. We have, I think these are last two. So in this one, I see a right angle. So let's check mark. And all of them are different scaling. So our angles are A plus 90 plus 36. It adds up to 180. So if you add up 90 to 36, you get 126. And I do the inverse operation. So regroup. A equals 54 degrees. So we have 54 degrees, 90 degrees, and 36 degrees. And let's do our hardest one of all, obtuse angle, more than 90. All the numbers are different, scaling. So if I added A plus 97 and 4/10 plus 31 and 4/10, all three interior angles will add up to 180 degrees. If you add up 97 and 4/10 to 31 and 4/10, 8, 8, 128 and, oh goodness gracious, it adds up to 128 and 8 tenths. So I need to do the inverse operation. What number goes above here? Placeholder 0. I need a regroup. So 8 becomes a 7. This becomes a 10. Then you regroup again. That becomes a 9. This becomes a 10. So it'd be 2, 1. So 51 and 2 tenths. So what we just did is we went classify 6 types of triangle: acute by angles, acute right and obtuse, by size, equilateral, equal distance, isosceles, eyes, 2 of them are the same, and scaling, getting our scale, always different sides. And then we found a missing interior angle. All 3 interior angles will add up to 180. So if you're missing one, you can still find it by doing the mathematics on it.